So in this problem here, somebody has already gone through the work of finding a solution to a DE. Now I just want to find A and B using these initial conditions. And again, it's perfectly fine. You don't have to do that by hand. It's perfectly fine to use some system of equations solver to do that. So maybe we'll write this up. Let me pause. Okay, so here was our solution. We don't even know what the DE was. Doesn't matter. Here are our initial conditions. So we're told y of 0, which will be a times e to the 0 would just be 1. So that'd be a plus b e to the 0 will also be 1. And that's supposed to equal 1. And then y prime, I have to find the derivative first. And you should just be able to do this. I apologize that my t's and my pluses look too much alike. But you should just be able to find that derivative pretty quickly. And then y prime at 0 will be a plus 5b because e to the 0 is 1. And that's supposed to equal, I got something in my way here, 3. So I've got this system of equations. A plus b equals 1. A plus 5b equals 3. Now, again, I would just solve this by hand. Come on, it's substitution. Like I solved this guy for A, plug in here, pretty quick. I just want to show you that there are many other ways you could solve this, and it's perfectly fine. If you were writing this up, say for a group assignment, your group assignment is going to have a very similar problem on it. Just get to here, show me this work, and then it's perfectly fine to say I used Wolfram Alpha to solve the system. I don't have to see all your arithmetic and your algebra. I want to see your calculus. You don't have to show me the steps solving this because I'm assuming that if you've made it this far, you know how to solve a system of equations. Okay, so how would we do this? Let me show you a few different ways. We could use Wolfram Alpha. So I could just type a plus b equals 1, comma, a plus 5b equals 3. I think that's what we had. So we get a half and a half. Yeah, those were the right answers. And then write up our full solution, plugging back a and b in. I could also, by the way, if you see we had A and B here, if you have like C1 and C2, you could probably do that here. You could probably type C1, C2. Like literally, I don't know if I've ever even tried this because it might confuse the system. Look how long it's taking. Yeah, that's probably confusing the system. If you've got C1, C2, C3, give them different names. Call them A, B, and C, X, Y, and Z, something like that. Subscripting your variables in a system of equations confuses the system here. Okay. There are also plenty of system of equations solvers online. Like here's one, Wolfram Alpha has one that's already set up. So like I'm not going to make you watch me figure these out, but there are plenty of system of equation solvers available online. See, here they want X and Y. I can't call it A and B. I think I have to call it X and Y. But let's try it. X plus Y equals 1. X plus 5Y equals 3. Oh, look at that. It even goes through all the algebra. So if you were writing this up, again, I asked you to solve some initial value problem. You would show this work, show your system, and then just write used whatever to solve it. Now, we're going to have more complicated systems later. So I want to show you something you're not going to be using for a while. When we get to Laplace transforms, we're going to have like 5 equations and 5 unknowns. And sure, we could do the same thing. I could come in here and type up all 5 equations, but there's so many opportunities to do that wrong. Like there's so many places you can goof. I think it's easier just to use your graphing calculator that you probably have in front of you. So you were supposed to learn this in pre-calculus. I have 2 copies of this software here. You're supposed to learn how to use the matrix buttons on your calculator in pre-calc. Not everybody got to that. So let me show you how we can use our calculator to solve bigger systems. Again, like I'm going to keep saying this, I would not have gone through any of this trouble for this. I just would have solved it by hand. I mean, my God, it would have taken less time to just solve that by hand. But it's good to illustrate how we would do it. So we get this matrix button there on the calculator. We want to write this system of equations in row reduced or in augmented matrix form. So I want to write this in the form AX equals B. So A will be my matrix of coefficients, 1, 1, 1, 5. My variable vector will be A, B. And then my solution or my answer vector over here will be 1, 3. Not 1/3, 1, 3. Okay, so that's just writing this system of equations in matrix form. Then we take the augmented matrix where we put A, 1, 1, 1, 5, put in this little dashed line, and then we bring this guy over, 1, 3. So this is a, remember, it's always rows by columns. This is a 2 by 3 matrix. So later on, when we get to Laplace transforms, you might have here like a 6 by 7. And you definitely don't want to solve that by hand. All right, so now I come into the matrix menu. So I got to hit second to get there. And I'll go to an empty one here. Oh, I want to go into edit. So I went over to edit. I'm going to go down to an empty matrix here and tell it it's a 2 by 3. And now I'm just going to type in this. And as I type, it scrolls across the rows. 1, 1, 1. I don't know if you can see what I'm typing here. 1, 5, 3. By the way, if you have any negatives in your matrix, that's the minus button. That's the negative button. If you have a negative, you have to use that button. Okay, now that I've got my matrix, I have a bad habit of accidentally messing up my matrix. So what I recommend at this point is get out of here. Quit. Second, quit. And then I like to check and make sure I typed it in right. So this isn't necessary, but I'll come back to the matrix menu, second matrix, go down to D and just hit enter a couple of times and check it and make sure it all looks right. And that's the same thing. That's what I got here. Okay, now we're going to come back into the matrix menu again, go over to math and go down to RREF, row reduced echelon form. And now it's asking me, what matrix do you want to apply this to? So I have to tell it D. And you might think, oh, well, there's a D right there. Look at that little green D right there. That's not matrix D. I have to go back into the matrix menu again, grab matrix D, and it will work if I don't put this parenthesis, but if I've got an open, I'm a mathematician. I want that closed parenthesis. and then I hit enter. And if your matrix, so if your equation has a unique solution, you will get the identity matrix right here. So 1, 0, 0, 1. And then your solutions will be here. This will be your C1, your X1. This will be your X2. So in this case, A and B, they're both 1/2. Okay, so you'll be doing stuff like that all semester. Somehow you'll be solving systems of equations. And in anything you write up, you don't have to show me all the steps. You could just say, here, use my calculator and the matrix function. And then, you would write down, like, let's write the answer. A was 1/2, B was 1/2. And then, of course, y equals 1/2 e to the t plus 1/2 e to the 5t. This was our final solution.